Hello there and welcome back to video 4. In this video we're going to look at how we can add an IP address to an interface and also bring the interface up so the router is essentially on the network. As you can see, task 4 here says please add the IP address 10.1.2.2 to the interface which is connected to the Calgary office and bring up the interface. So just switch over to GNS3. As you can see, this interface here, Fast Ethernet 1/0, is connected to the Calgary office over here, which is also connected on Fast Ethernet 1/0. We just need to worry about the Toronto office right now. So we're going to pull up the console, already in enable mode. Go into configuration mode, and it's interface Fast Ethernet 1/0. Will drop us into the interface level config. You can see that here. This denotes that we're at the interface level. First thing we're going to do is actually bring up the interface. In fact, let's come out for a second and I want to show you the interface in its current state before we do that actually. So show interface Fast Ethernet 1/0. And this, I'll just make this a little bit bigger for you. This is going to show you all the information on Fast Ethernet 1/0. You can see things like the duplex here, which we haven't really talked about too much. This is a 100 meg full duplex and encapsulation, and you can see things like CRC errors, input errors, all this kind of stuff, collisions. It's quite a useful page, especially when you're troubleshooting what you suspect to be like physical cabling issues or duplex issues. Its current status at the moment, which is probably the most important thing, is administratively down and line protocol is down. So I want to show you what happens when we go back into configuration mode, back under the interface again, and we're going to do a no shut down on that interface. Cisco has this sort of syntax where instead of enable or disable, they have shutdown and then no shutdown. No shutdown basically means enable. It's a Cisco thing. I don't fully understand it, to be honest, but as you can see there, here are the console messages. You can see the port is actually coming up now. If we do a quick copy and paste, because I'm lazy. 1 second. Here we go. Oops. Put the do command first. Now we can see Fast Ethernet 1/0 is up, line protocol is up, all is good. It's actually able to pass traffic and is actually passing a little bit of traffic. Very, very limited traffic, obviously. So now what we need to do is add an IP address to this interface. I also want to show you a quick command. Do show IP int brief. If I can spell. Probably one of the most useful commands, really. In the iOS, it's probably the one that I use the most, that and show run, obviously. At the moment, Fast Ethernet 1/0 is up, and the protocol's up, all is good, but it doesn't have an IP address. It's showing as unassigned. You might notice down at the bottom there that I have a loopback 0 address. That's not an actual physical interface, that's a what you call loopback interface. It's software, in software only, basically. I set that up to create this network here, and we're going to do some fancy routing stuff with that in later videos. So you can just ignore this now, imagine that doesn't exist. Our router out of the box will have no IP addresses configured. So we go into interface Fast Ethernet, back under the interface mode, and we're going to do the IP address. Let me just check what IP we said we would use. Let's have a look. 10.1.2.2. 10.1.2.2. Subnet mask. This subnet mask that you see here is a /30 subnet mask, and you'll see that on WAN links generally. So sort of point-to-point links, you'll generally see this in an Ethernet environment anyway. So question mark and enter. We now have that particular IP address set up on the interface as requested. The interface has been brought up, everything's great. We haven't set up Telnet or SSH or any other method of remote access yet, so you still can't get on the router from Vancouver in this instance, but we're going to be doing that over the coming videos, so you should be able to see that and how that works. At the moment, we should, at the very least, be able to ping the other side of this link, which I believe is 10.1.2.1. So if I ping 10.1.2.1, assuming that the Calgary office over here, let me show you that, assuming that this interface is all configured correctly and this route is fine, we should be able to ping that IP address and we have some network connectivity. In theory. Yes, there we go. So as you can see, the first ping request, the first ICMP message, actually timed out. This is due to the router actually having to acquire the other router's MAC address via ARP. But all subsequent pings should be successful and are successful. So thank you for joining me in this video. I look forward to seeing you in the next video.